Okay, in this video we are going to look at Chapter 7, which is hypothesis testing. You know that's the second most common type of inferential statistics, right? We did confidence intervals where you estimate a population parameter. In this one, we are going to make a claim about a population parameter, and then we're going to take a sample and calculate a statistic and use that to give evidence for the claim or not. Okay, so let's get started. All right, so for hypothesis testing, you know what that is. There's two parts. There's what's called a null hypothesis. The first one is the null hypothesis, and the second one is the alternative hypothesis. Okay, so these come in pairs. Anytime you do a hypothesis test, you have two. Right? This is the null and this is the alternative. Okay? And the hypothesis is about a population parameter. So I'm just going to invent this and say the population mean is greater than or equal to 13. And the alternative to that would be that it would be less than 13. Notice these are complements. Right? These are complements. If it's not in this set, it's going to be in this one and vice versa, right? It's either greater than or equal to 13 or it's in this one. And the equality is always going to be in the null. All right? Sometimes this is going to be less than or equal to, sometimes not equal to, sometimes great. But the equality is always going to be in the null hypothesis. And the alternative hypothesis will never have the equality, okay? And typically, just to tell you, this is typically the claim, all right? Now, that's not always the case in the book. Sometimes sometimes the book, for whatever reason, makes the claim the null hypothesis. I think they're just trying to get you to think about what you're doing, but typically you want it in the alternative. All right, so, and maybe there's a case and I just don't know about it, but anyway, that's the general rule. The idea is that you want to get a test statistic, I should say a test statistic. What is that? You make a claim, all right, you set up your hypotheses, and you assume that this one is true. So here I'm going to assume that the mean is greater than or equal to 13. And then I'm going to go get a sample, right? I'm just going to go take a sample, and I'm going to get a test statistic, right? I'm going to calculate a statistic from my sample, and I'm going to look at that number and compare it to the 13. Compare it to what I'm trying to say. And if it's very far, if this number is far from the 13, then I'm going to reject this because this has the equality in it. And this is what I'm assuming is true. If this is true and I get a really far out number here, that means that this is likely not true in favor of that. And that's how the test works. Okay? So let's set this up. This, just like the confidence intervals, it is based on the sampling distribution. All right, and so from the central limit theorem, I know that the mean, the sampling distribution, has a bell-shaped curve, a normal curve. If my sample's great enough, large enough, and it's centered on the true mean, okay? And so it has this shape. Now, what we want to do is, in this case, so we take the equality, we take the equality and we assume this is true, right? So we assume this is centered on 13, and the idea is that we want to get in our sample a value that is really far from this, so that I'm just not likely, if this is true, I'm not likely to get a sample in this region, all right? And the area of this region is alpha, and that's called the level of significance, all right? And alpha is also equal to the probability of a type 1 error. It's the probability of a type 1 error. So what is that? I'll just write it here. It's the probability that you reject H0 when in fact H0 is true. All right, so let's just, it's also the area of this region here, the rejection region. Right, so let's just say alpha is equal to 0.05. And this is something you determine beforehand. Say I want to use a test with an alpha equal to 0.05. So let's think about this type 1 error again. What does that mean? If I took a sample, most of my samples are going to be here, right? And it's not likely that it's only a 5% chance that I'm going to get one in here. So if I do get one, it's likely this isn't true. However, there is a possibility that even if this is true, I do just by chance get a sample that lands over there. And when it lands over there, I say, oh, that's not likely, that's not true, that's probably not true. But in fact, I made a type 1 error. Just through random sampling, I ended up getting a sample. There's a chance I could get one here, right? Not likely, but it could happen, and that's the type 1 error. So the alpha it's the area of the rejection region, all right? It's the size of that rejection region, and it's also the probability that I could get a type 1 error. Okay. Now, one last thing here is this. Okay, I think that's, well, let's do one more thing. What's a p? Something called a p-value. Right. So I'm gonna blow up this little section here. All right. So here's the tail. Here's the tail. And this is my rejection region, alpha. All right, alpha. And, well, I'm sorry. Alpha is the area, 0.05, right? This value here, in this case, I don't know, maybe this is 10 point something. There's a value here that gives me an area of 0.05. This is the critical value. All right. So here's how the test works. If I get a test statistic, right, maybe my X bar lands here. Maybe my sample statistic was here. It lands in the rejection region. All right. So the test statistic, this is the test statistic right there. If that is, in this case, if it's less than the critical value, less than or equal to the critical value, I'm going to reject H0 in favor of HA. Let me say that again. All right, so I assume this is true because of the central limit theorem. I'm going to make this sampling distribution, and then I'm going to take a test statistic. If my test statistics, if it lands in this region here, I'm going to reject my H0 in favor of my HA, all right, of my alternative hypothesis. If I get it up in the test statistics up here, it's greater than the critical value, then I'm not going to, I don't have evidence for anything. I don't know if this is true or not. I got one in here. It doesn't tell me anything. The true mean could be here, and it's just as likely I'd get that same point here. So I can only reject this if I assume this is true and I get a data point down here, a test statistic down here. All right, so that's how it works. you compare your test statistic with the critical value, and let's just put some numbers in here. I'm making these up. This is 10.5, and this one turns out to be 9.23. And if I got the 9.23 and it was less than the critical value, I'm going to reject H0 because it's not likely I would get something in that region. All right, now the last point here, well, there's really two more points I want to get to. There's something called the p-value, and what is that? That's the area. The p-value is the area that's created by the test statistic itself. All right, so this area, all right, so this area. Another way you can do the test is look at the area created by the test statistic, right, the p-value. And if that area is less than 0.05, then that means your test statistics in this region, like this is, I don't know, let's just make something up here. This is 0.15, right? My p-value is equal to this area, which is 0.15. And since that's, whoops, I'm sorry, 0.015. Since that's less than 0.05, if the p-value, if the area of the caused by the test statistic is less than the area of the whole region, then you're going to reject H0. I hope I didn't screw you up there. But that's what the p-value is, the area that is calculated by the test statistic. And it's basically the probability that I get a test statistic of that value or one that's less. And these would all reject H0. Okay, so last point here. When you set up these hypotheses, all right, the one that we had, H0, was the mean. Is that on there? Mean is greater than or equal to 13, or the mean is less than 13. All right, so that's where the rejection region is here. This is called a left-tailed test. Left-tailed. All right, left-tailed. And it is based on the alternative hypothesis. So there's two other ones. All right, so if H0 goes the other direction where the mean is less than or equal to 13 and the HA is greater than 13, all right, so that's your critical region here, your rejection region. So that's going to be right-tailed. And the last one here is when your H0 is, the mean is not equal to 13, or I'm sorry, the HA is the mean is not equal to 13. This is, erase that, just the mean is equal to 13. And the rejection, the alternative hypothesis is not equal to 13. That's called a two-tailed test because it could be in either direction. Right, this is two-tailed. Notice here that the equality is always going to be with your null hypothesis. Okay, there's the equalities in each of these. And the idea is you want to get a test statistic that will reject, that will land in one of these regions, and then you will reject the H0 in favor of your alternative. And that's the hypothesis, that's the test. So, oops. Anyway, I hope that makes sense. I would prefer to do this in person, but this is what we're limited to. So anyway, get started on 7.1, and I'll put another video out for the next lesson.